Remember in your results section not to include any SPSS output except I would love for you to put one figure in, one chart. And this is what I'd like you to do. So here I've got this data set that Field is showing us, and it's the Viagra data set. And what he did was he gave people a dose, either the placebo, a low dose, or a high dose, and then he measured from 1 to 7 their libido. So what we're going to do first is just make a quick graph. Here in Chart Builder, I want to show you a cool bar chart that we can make. And basically in this bar chart, we're going to put our dose here, our categorical variable. Okay, so dose right here. But then we don't have a count in dose, except we know it looks like 5 people got each dose. What I'd like to do instead for the bars is have the mean of libido. If I drag libido over here into my count box, gives me the mean of libido. And look at this nice bar chart that SPSS gives me. So I know the placebos had a mean a little over 2, the low dose were a little over 3, and the high dose were up here around 5. That's a very nice visual for me. In fact, that's a great segue into ANOVA. Okay, so when I look at these, I say, yeah, those 3 groups were different. But is there enough difference there for it to be statistically significant? Well, there's one way to find out, and that's by doing ANOVA. By the way, if you'd like to see instructions for creating this type of a bar chart, they're in Chapter 4, page 144, 145. That will give you a sense of how you can create a bar chart like this. And I'd like one for the teach data and one for the super costume data. Okay, so now let's go back to our spreadsheet here. Let's go into Analyze and let's do under Compare Means, the one-way ANOVA right here, okay? I am going to conduct a one-way ANOVA. Let me reset this. We'll start over. My participant variable, this person variable really doesn't matter, right? Each person was given a number. What I'm really interested in is their libido after I gave them a dose. That means dose is my factor. That's what I gave them. And libido is my dependent variable. That's what I'm interested in. That's what we're going to look at here to see if there's a difference. Now, in the book, so to find instructions for creating this ANOVA, you'll go to page 460 and 461. Then we won't do the planned comparisons, although they're very valuable. They're something that many people use. However, in the publications I've seen, it's even more common to find the post hoc tests. And so let's go straight to the bottom of page 463 and conduct these post hoc tests. Now, everyone has their favorites and everyone has the ones they don't really like. I would like you to click on post hoc here and to choose the Bonferroni. This is a very conservative test. If it's significant in Bonferroni, you know you found a difference. I also really like Tukey because, so what Bonferroni does is it kind of punishes you for comparing more than 2 things at once. It takes the p-value, and in this case, it would divide the p-value by 3 because there are 3 different dose groups. So now to be significant, instead of being 0.05, it has to be 0.05 divided by 3. It has to be 0.0167. That's Bonferroni's idea. Tukey's idea is even better. He compares things 2 by 2. So he'll compare 1 to 2, 1 to 3, and then 2 to 3. And as a result, the p-value isn't diminished as much as it is in the Bonferroni procedure. And then I really like the Dunnett procedure because what he does is he takes a placebo group or a control group and compares it to each one systematically. In this case, the Dunnett control category automatically says last, but for ours, we know from reading the field book, It's the first category. These ones got the placebo. So I change it from last to first. Okay, let's continue here and let's see what we get from SPSS. Well, first of all, so here's our one-way ANOVA. And we have here this sum of squares. This is going to be, so I'll copy and paste these into a Word document. Remember, please don't turn in this Word document, this copied and paste for the final homework assignment. This is just for our purposes and for practice. I'm also going to copy and paste this into a Word document because I'd like to show you what's important here. Okay, and when this table doesn't quite fit on the page, I get in here into the layout. I come here to auto fit and I auto fit to the window, and then it usually cooperates and fits. Okay, so we are going to use this between group sum of squares right here. And let me just highlight this. We are going to use that sum of squares and this sum of squares to come up with the effect size. So let's skip really quickly to the effect size calculations that Field does on page 472. And he calculates eta squared. So he takes the 20.133 divided by 43.73. That is 0.46. So just make sure you go to, I'm not going to type these in here, but I want you to make sure that you feel comfortable with page 472. Okay, so he comes up with 0.46, and then he divides eta squared, or he takes, I'm sorry, I apologize, take the square root of eta squared to come up with R. And he comes up with an effect size of 0.68. And he calls that a large effect, which I would agree. Often I say 0.7 is large, but 0.68 is very close to 0.7. So this is a large effect. That's telling me, okay, if I find something significant, I can say we had a large effect there. That's why you need this ANOVA table. Why else do you need the ANOVA table? Because you're going to report the F, the degrees of freedom, and we report both this one here and this one here. Okay, so F, the degrees of freedom, and the significance. Okay, right off the bat, what do you notice? This test was significant, so we can reject our null hypothesis. What was our null hypothesis? It was no difference. We can't do a one-tailed hypothesis anymore. So our research hypothesis was there will be a difference in libido depending on dose of Viagra. Okay, and what we found here is that there was a difference. We're rejecting our null. We'll say there was a difference. And here we'll report F. Remember, we have to put both degrees of freedom. So 2, 14 equals, and it equals 5.12. And then we put P equals, and P equals 0.025. Make sure you go in and put italics on your F and on your P. Okay, so there's our ANOVA test. We say there was a difference. I would also like you to report the mean and standard deviation of each group. And if you remember, you can get in here. Let's go back and just make sure we calculate that mean and standard deviation in Analyze. Here in Compare Means is a nice way to do this. Click on Means, and then we want the means for the different libidos, but here in our independent list we can put the dose, which is very nice because then it will separate out our means by placebo, low dose, and high dose. So make sure that you calculate those, come up with those, and report those here in your paper. Okay, but remember again, not this SPSS output. Write it in your own words. Italicize the M and the SD. We're going to just continue to practice over and over and over again, writing this up as if it were a journal article. Okay, and then finally, the multiple comparisons. Now, here's what's a little tough. I went ahead and printed out Tukey and Bonferroni and done it. But for your comparisons, you need to decide on one that you feel best suits your data. As a general rule, I would say anytime you have a control group or a placebo, as in this one, use done it. So in our case, I'm going to have all of this on one page. In our case, because there was a placebo, I'm going to use done it. For the homework, you may want to use Tukey. Tukey is probably the most common, the most well accepted among statisticians. If you do find a significant result in Bonferroni and would rather use that, you may. People will respect the fact that you used the toughest test and still found a significant result. So now in here, this information lets us know what's being compared. We don't need the mean difference. We don't need the standard error. And we're not going to report the confidence intervals either. All we need are the significances. So since I already said I'm going to use done it, I look down here. Here's the low dose versus the placebo. It's greater than 0.05. So this was not different. It's not statistically different anyway. But look at the high dose versus the placebo. Here, P is 0.015. And so I'm going to report, first I'm going to tell my reader why I chose Dunnett's. I chose Dunnett's test because it was specifically designed for a placebo type or controlled type study. And then the statistical difference was between the high dose and the placebo. And here I'm putting Dunnett's. You can tell me previously that you used Dunnett's, but basically you just put the P. We don't, in this one, this is very unusual, we don't put a statistic, like this isn't an F or a T, and we don't have to put degrees of freedom either. We just put our Dunnett's, maybe I'll put here Dunnett's test, or Dunnett's post hoc test. That would be even better, wouldn't it? So everyone knows. And then that the p-value was 0.15. It's less than 0.5, and so now we can say that's where the difference lies. If you chose Tukey, for example, look right here. Here it is, 0.021. There's a significant result, and sure enough, it's placebo versus high dose. Notice that Tukey has some repetition. Here's the same result, 0.021. It's high dose versus placebo. If you chose Bonferroni, this is the toughest test. High dose versus placebo is 0.025. So you still have a significant result. Notice it's not quite as significant. Remember, the lower the p-value, the more significant it is. Dunnett's is the most significant, and that's one reason I like it. It was set up for this type of test. But even if you chose to use Bonferroni, and that's the hardest test, we still have a significant result right here. We cannot say there's a difference between low dose and placebo. Basically the same because P is greater than 0.05. But we can choose one of these. And for the homework, choose whichever one you'd like. I'd recommend choose Tukey for one and something else for another, so that you have two different approaches, since I've given you two different data sets, just for fun, just to show that you're practicing talking about some of these different post hoc tests. And then The effect size goes up here, excuse me. So you have the mean, the standard deviation, and the effect size here is going to be R. So post that. Tell us whether it's small, medium, or large, and you can use a little bit of interpretation on that one. Huck has some good numbers in his book for that. And then write it up as if you're submitting it to a journal, a one-page journal brief. Okay, well, thanks for watching, and good luck with this.